Hello. It's another beautiful day in my shop. And anytime I'm in here, if I can eliminate or minimize how many times I take measurements off of this and transfer them to a workpiece, I'm going to, because that's where we invite mistakes, right? So how do we minimize that or mitigate or eliminate that problem? We use stops, blocks, and spacers. Let's jump right in. I'll show you more how to get more accuracy into your workshop every time you come in here.
All right, so here I have a sample of some material that I would be putting a groove in, let's say for a drawer bottom. And we want to put it a 1/2 inch up, like for an undermount drawer slide. Now, we know that plywoods are typically undersized because they're probably metric. It's probably a 6mm. Anyway, it doesn't measure 1/4 inch. It's more like 226, 227 thousandths, somewhere in there. And that's fine. That's the number we need. Incidentally, don't measure off a factory edge. It'll be thinner on those edges because it's been sanded. For whatever reason, they're thinner on the edges. So make sure you measure a cut side. Then I'll simply record that, right? We'll just write that number down. And of course, if it was metric, it would be, let's see, 5.7mm. All right, now we can measure the blade, but we know it's an 1/8 inch, right? Here's an 1/8 inch spacer, about an 1/8 inch, or 0.125. Metric would be, let's see, I wrote it down here, 3.2. And we'll subtract those two. Here, let me get a marker. This is the magic number. So in my case, 102 thousandths. Now, I've already made a spacer, right? And I just made it a little bit big, and then I just sanded it. And it measures 103, 102, somewhere in there. Close enough. Perfect is close enough, right? And I've added a block to the end. I'll show that here in a bit. We add our spacer, and we want to mimic this 1/2 inch space that we're coming up from the bottom. So we'll put a 1/2 inch spacer in here. Boom, 1/2 inch. Bring everything up to the blade. Here's that little block that just keeps this from moving while we make a cut. Check this out. This is so awesome. I'm first going to lower the blade, and I'm just going to go, I don't know, halfway through for this demonstration. Doesn't really matter here. Okay. Let's make this cut. Of course, this spacer could be longer if it needed to be. It could be taller. You could tape it in place, all that, right? We're going to make our first cut. Boom. We'll then remove the spacer automatically. You saw it kind of get caught by the blade there. No big shake. Something that light and small is harmless. Make our other cut, and boom, it is that easy. Here's the proof. Now, of course, this is a little bit tight, and so you could sand this, finish sand, top and bottom, and you'd have a beautiful, perfect fit. Check that out. No messing with dado blades. Now, of course, this would work at a router table or a bandsaw, but it's an easy way to get perfect grooves by just using a spacer. So, of course, the spacer plus your blade thickness equals the groove size or the material of the panel, whatever you want to cut. Beautiful, yeah?
So this one's probably pretty well known. Let's say you're doing an inlay in a workbench, or you need to make a cavity and you want a certain depth. Well, you can bring the router bit down. You can see I have a collar on there, but it won't really matter. So you can bring the router bit down till it just makes contact with the work. Right there, and you lock the plunge action in place. And then here with your depth stop, let's say you want to go down whatever distance it is. Maybe I want to put a 1/4 inch melamine inlay in my workbench. I would just put that in place, drop this plunge rod down, and we're going to make a cut exactly that deep, right? Or if you're doing hardware, you just use your hardware. I think this is pretty common. Another thing I like doing is if I need a specific depth, I use a drill index. These make excellent spacers. Here we have one that is 185 thousandths, number 13 bit. I can put this in place right there. And we're gonna plunge down exactly that depth.
These are machinist blocks. They're called 123 blocks, 1 inch by 2 inch by 3 inch, or you can get them different sizes. They are extremely useful. You should get yourself a pair. You won't believe how often you use them. Of course, I could just use one by itself, but here I'm calibrating the scale on my fence. I know that from my blade with 2 blocks to my stop is exactly 6 inches.
All right, here's a great example. Stops, blocks, and spacers. So I'm cutting these little 15-degree, actually 22.5-degree clips on the ends of these. And when I first started setting this up, I wanted this cut to be right at the end of this diameter, radius, whatever, right? And I was a little bit off. Rather than adjusting this, I just added two pieces of tape, and that shifted it over just enough to make a better cut. Then I needed to make I had to do another operation where I had to move this. So what I did is I set up this guy, a block, a clamp. Then I was able to remove this, make my other cut, and then to put it back, I know I'm going to be back in the same place. Boom, tighten that down. And then this last piece that needs those 22.5-degree clips, I know I'm set and ready to roll. All right, so I'm making these drawer fronts / handles to fit these pieces. This will end up being a blade storage box. Let's see, this will go like that, okay? And so I'm just creating this rebate or this rabbet on the bottom of the handle that corresponds with this thing. I took a router and had a bunch of these, so I was able to gang a 3/8 round over to create these radiuses to match these radiuses, cutting everything to fit. But I've noticed that the rebate here on this that show up is just a little bit too long. You can see it moving back and forth. Now this distance here is exactly the same as this distance. So it would be kind of tricky to move each one of these stop blocks in the amount that I want. So I know that 4 pieces of tape, of blue tape, is a 64th, which is about what I need to move over. If I could peel this. So I can simply just add a couple of pieces to each side. A lot easier than trying to move both of those stop blocks, right? Boom. I can run. My next ones will be accurate. So, yeah, very effective.
This is my blade storage box, and you can see why I was being so, careful, critical, accurate. All the ends, I wanted them to line up, which they do perfectly. I love this thing. I made a video on it, so if you want to see that or you missed it, I'll leave a link in the description. Here I'm making an awesome table saw insert, but I made the file upside down, and this opening needs a rebate around the perimeter on the top, but this piece is upside down. So I'm going to add some spacer blocks. That way I can release this and continue to create that rebate and not lose my place with the file for the shaper origin, the DXF file. SVG maybe? Yeah.
So I can't just, I can't put something here and here and flip it over. It would throw off this. I need that hole to be in the same position. And it's not super critical, but this will get us pretty close.
And yes, I could have just used a handheld router with a rabbiting bit with a bearing, but the radiuses would have been too big.
When it comes to double stick tape, I find it easier to try to scrape it to get it to release from the backer rather than trying to get in between them. Just kind of scrape it on a corner. That usually does the trick. So now I can index this. Wow. All right, let me drop this blade down. And I guess we can get rid of this. Get rid of that guy. Check it out. Awesome, yeah. Gonna love that. So even if I have a bigger blade on here, like a 12-inch blade, so I have a non-ferrous blade, it's the only 12-inch blade I ever put on here, and it'll cut, you know, a little bit. It might cut the insert completely. It won't hit the screws. And the magnets are out of the way as well. That is awesome. Made a bunch of those. So yeah, fantastic addition to the shop. All right, I'm gonna start cutting the miters on this box, and I've done a couple of things. I took, let me grab a square here. I've taken a square, put it here, and it literally took only one piece of tape to put here, and so that's about 4/1000, 3.5 thousandths to make this dead on square. Same here, over here it was square. I'm using a light behind the square, viewing it from here, and I can make sure that that is dead on square, right? This old DeWalt saw is pretty accurate. And then, this is the outside of the box. This is gonna get a miter like this. I like cutting my miters this way, rather than this being the outside of the box and cutting the miter this way. In this situation, for a couple of reasons. The first reason is that I believe the wood fibers are cut cleaner cutting this way. Remember, this is my outside. So I'm cutting, favoring the grain and the fibers of the wood. Think in terms of a paintbrush. That was my buddy David Bedrosian's analogy. A paintbrush as related to the wood fibers being cut. They're in favor of that blade direction. As opposed to cutting like this, all these wood fibers are cutting into them. So anyway, I like cutting it like that. I've set up a stop and a spacer here so I can move the spacer out of the way. I can bring this right up to that. I'm gonna cut right at that corner. And I can clamp this to make sure that this piece doesn't move. Then I can remove the spacer so I don't cut the corner off. And I can make that cut. This saw is barely cutting this dimensions, about 5 3/4, I believe. And I had to temporarily hold my guard up and out of the way. This top edge of the board ends up bottoming out on this aluminum housing. So I couldn't cut it the other way. The motor would definitely hit, but this is working well. Check it out. Yeah, it's a little scary with the blade exposed like that. I stand off to the side, and hey, if you don't want to do this, absolutely don't do it. To me, I'm just paying attention, and it's fine. A couple of things. You can see just a tiny little bit down at the bottom that doesn't get cut. I think you can see that. But that'll get cleaned up because I'm going to hit these with a shooting board and a shooting plane. And you can see this is a newly sharpened blade. It's a ATB grind, which I like for doing fine work like this. I believe it's a 96 tooth. This is a 12-inch and almost zero saw mark, so it's a pretty clean cut. Of course, it's going to be clean on this side, and you can see that this other side is also perfectly clean, so that's going to make a good cut. I mean, that's going to make a good miter, and that looks to be a little out of square for whatever reason. It is a tad off. Could be the wood being warped, a lot of factors, but we're going to be hitting this with a shooting board and a shooting plane anyway, so it's a good place to start. So now that I have a miter cut on each piece of the box, I can take these, put them together, and take the shorter one, this one, slightly shorter. Doesn't really matter at this stage. And I can put it here, again, using my stop and my spacer. Bring it right to it, and I know I'm going to be cutting right from that corner again. Clamp that dude in place. We'll make the cut, and then to match the other one, let me tighten that up a little. Didn't seem to lock like I wanted it to. Okay, and we can remove this dude. And now I'm just going to put a little mark here, 0.5 millimeter lead pencil, very fine. Again, these just need to be as close as possible since I'm going to be hitting them with a shooting plane and a shooting board anyway, right? Now, I could have done this at the table saw. This might have been another way, maybe a better way to do it, but I know that this saw produces really nice cuts, so I just stuck with the chop saw for now. A lot of ways to do things, yeah.
Miters are one of those things where I believe that most people think that's pretty simple, and in fact it is, but careful prep is absolutely important. So to put things in perspective, a 4-sided box requires 8 accurate cuts, right? 45 degrees, not 44 3/4, not 45 1/2, 45 degrees. This curved piece will become a drawer front, and I need to cut a rebate for the drawer bottom. These 2 little blocks of wood, they're also curved because they're just fall off. I can clamp those in place, and that'll give me a positive stop for the bearing to bump against. Note that the stop block on the tail end also proves to be needed for a clean exit. I'll begin with a climb cut. That first pass will be a climb cut, and that makes a much cleaner cut. I use leverage from that block of wood holding the hose to engage the router bit and router bearing. One hand, at least one hand, is always holding the work steady and firm. I can make that first pass and then make a conventional cut the other direction. Boom. Beautiful, clean rabbit. Rabbit? Rebate? Rebate reminds me of a coupon or something a frog would say.
All right, working on the Pantorouter today, and I made a test cut here. What I'm trying to do is fit some 1/2-inch Baltic birch for a table I'm making. I'll show you that in a bit. So I don't have a bit that size to make that one pass. So I've got a 1/4-inch bit in here. And what I'm going to do, let's just go through this. I've got one of my Pantorouter stop blocks that I make and sell. So I'm going to bring that up to that. Let's clamp this dude in place. Okay, so my target dimension is, all those guys across the pond are going to hate this, but 1/64 under 7/16, right? So my bit is 1/4-inch, so I need to add 4, 8, 9, 10, 11 64ths. Boom, 11 64ths drill bit. I can loosen this dude, slide that over, put this 11 64ths drill bit between my stop block and the end of my work. Bring this back over, lock that in place, and we'll go ahead and cut the rest. I left the shield off just to show the bit in action, but all right, let's go see how we did. This probably won't make a lot of sense, but this is a skirt to a table, and of course this is still wild. This needs cut, notched. It'll be like kind of like a Maloof joint, but I needed to create this dado size to fit this plywood. Just perfect, right? I'll do one on each side. This will get a notch that'll slip in there. There'll be another layer going on top. We've got curved drawers going in here, pivoting drawers. Yeah, there's a lot going on, but that's awesome, right? Stops, blocks, and spacers. That's where it's at.
And ultimately, fitting one of the legs in place This proved to be an extremely strong connection. And if you haven't already, watch this video. I poured my heart and soul and tons of hours into this table build. I'm working on a batch of zero clearance inserts, and they need 4 holes, 7mm holes, spaced accurately from each end and one edge. So they fit the machine, actually several different machines, whether I'm making 1 or 100. I made a basic jig or cradle that gets anchored to my drill press table, and then I can use a series of blocks and spacers to drill those holes even though they're not in the same alignment from the edge. Works amazingly well, quick, easy, repeatable, all that. Here is how I set this jig up to begin with. I've got this hardened bushing, right? And I can bring that 7mm drill bit where it just engages. I make sure it's centered, and then I can lock my quill in place. That's fantastic. So now, even if this jig is twisted, doesn't matter, that engaged drill bit into that bushing means that I'm in the exact location for hundreds of these zero clearance inserts. And of course, when I go to drill, the drill press quill is set to not allow the drill bit to contact that hardened bushing. I find it odd that every single sliding table saw that I've ever seen or worked on doesn't have a proper zero clearance insert. If you don't have one, you need one. Check out the website, blah, blah, blah.
Here's another good one here at the drill press. So I'm making these blocks. They're 1/2-inch aluminum. I make hundreds of these, and these are blocks for a clamp for sliding table saws, K3 and some others. Anyway, I leave them long on a bar like this, and not too long, because when I cut these, I'm cutting this with a table saw, right? Skill saw, yeah. So I'm cutting these with a table saw, and sometimes this aluminum is not dead straight. And I can do manageable size pieces like this.
So in this length, they're pretty damn straight.
Drill all my holes, tap all the holes, and then cut them to size, right? So to start, I simply mark 2 holes with an 1/8-inch space allowed between them for the saw blade. And then I've got a drill bit drilled in this block. Once I have that first hole drilled, I can slip it over that. Must be a burr in there or something. Drill a second one, and then continue moving this down, drilling subsequent holes, and they're all going to be spaced perfectly. And then when I go to drill a new one, all I need to do is put this first one in position, and I need to account for that saw blade. Here's an 1/8-inch drill bit, place it right there, and boom, I'm ready to go. How awesome is that? I'm telling you, blocks, stops, and spacers. That's how you stay accurate.
Oh, and I'm excited to show soon. I just ordered a Tapmatic. It's a tapping head with a reversing clutch, so you can tap threads right at your drill press. All right, here's another good one. I'm making some box joints, and I'm trying to sneak up on a perfect fit. These are too loose. You can see that piece won't even stay in by itself. So I need to move my spacer block over, and I assumed 2 pieces of tape would be about right. So what I'll do is clamp a sandpaper block to my little crosscut sled with that tape, those 2 pieces of tape in between the spacer block and this clamping block, right? Now I can remove the clamps, or loosen the clamps, scoot the spacer block over, remove the tape, bring the spacer block back, clamp everything in place. This works so well, way better than trying to add a mark and tap it over slightly. There you can see the box joints. They came out beautiful and tight. Tight is right. And that is a wrap for this video. I certainly hope you got some good ideas. Remember to include and incorporate stops, blocks, and spacers in your shop routine, and watch your accuracy improve.